We are going to continue with our learning target. I can use numbers written in scientific notation to express how many times as much one is than the other. So we're going to be looking at the comparing portion of that target. So to compare two numbers given in scientific notation, you're first going to compare the exponents. The one with the greater exponent will be bigger or greater. If the exponents are the same, you're then going to compare the decimal values. So if we look at our first examples here, number 1, I'm first going to look at my exponents. So if I compare my exponents, I have 5 compared to negative 7. Well, 5 is greater than negative 7, therefore 2.56 times 10 to the 5th is going to be greater than 4.2 times 10 to the negative 7th. It's as simple as that. So if we look at number 2, I'm going to first look at my exponents. I see I have 4 compared to 6. Well, 4 is less than 6, so we would say that 4.3 times 10 to the 4th is less than 1.6 times 10 to the 6th. Moving on to number 3, I notice that my first value doesn't have an exponent. So in order to compare the exponents, I do need to write that value written in standard form back into standard notation, into scientific notation. So from our previous lesson, we learned my decimal is at the end of the standard form, and I need to put it to a location that creates a value that's between 1 and 10, which would be 5.1, and that is 1, 2, 3 swings. So this would be 5.1 times 10 to the 3rd. Well, if I now compare my exponents, I see that they are the exact same, so 3 is equal to 3. So before I can assume, or before I can say that these are the exact same, even though, side note, I think many of you can already see that they are, for practice sakes, we would then look at the decimals, and I have 5.1 compared to 5.1, and 5.1 is equal to 5.1, therefore 5,100 is equal to 5.1 times 10 to the 3rd. If we look at number 4, again I have a situation where my exponents are the exact same. So I have negative 4 is equal to negative 4. So now I have to look at my significant digits, and I can see that I have 4.32 compared to 4.3. If it helps, you can add a 0 to the end of the 3. Remember, we can add as many zeros as we want to kind of have a balanced comparison. And so 4.32 is just slightly greater than 4.3. Therefore, 4.32 times 10 to the negative 4th is going to be greater than 4.3 times 10 to the negative 4th. And our last example here, if I look at my exponents and I compare, I have negative 7 compared to negative 8. Be careful when it comes to negatives, because negative 7 is greater than negative 8. Remember, the larger the digit is in the negatives, the smaller the number it actually is. And for our last example here, it says put the following numbers in descending order. Descending means that they are going from largest or greatest to smallest. Okay, now when you have different representations like we do in this example, the best way to compare them would be to get them all in the same form. So 45%, hopefully we recall from previous grades that it would be 45 divided by 100, which is 45 hundredths, which is 0.45. My next value is 4.6 times 10 to the negative second. If I am changing that into scientific notation, my decimal is going to swing 2 places, or it is in scientific notation. If I'm going to change it into standard form, I'm going to swing the decimal 2 places to the left, so that would give me 0.046. Half we hopefully all have memorized as 0.05, and then my last digit is also already in decimal form. So if I'm putting this again from greatest to smallest, the largest number that I have there would be half. So 1/2 is going to be my greatest value, so that is what I'm going to start with. So I'm going to cross that off. Notice that I am writing it in the original form that it was presented in the problem, not the decimal that I converted it to. So after 1/2, I'm comparing 0.45 to 0.046 and 0.045. Well, 0.45 is going to be larger than those other two, so 45% would come next. And then comparing 0.046 to 0.045, well, 46 is bigger than 45. So 4.6 times 10 to the negative second would be next, and then last would be 0.045. In question 7, it says to list the planets from least to greatest. So we're going to first start by looking at the exponents and trying to find the smallest exponent. So if I look at all of my values here, I see that 23 is going to be the smallest exponent that I have, and I have 2 that are in that category, or with an exponent of 23. So then I'm going to compare their significant digits, and 3.30 is smaller than 6.42. Therefore, Mercury is going to be the smallest planet, or the planet with the least mass. Mars would be after. Okay, so we have now used Mars, we've used Mercury. Now I'm going to look at my next exponent, which would be 24. 24 is my next smallest exponent. And again, I'm going to look at those significant digits, and I can see that 4.87 is smaller than 5.97. Therefore, Venus is going to be the next smallest, and then Earth would follow that. All right. Then if I go ahead and look at my next values, so we had an exponent of 23, 24, then I would look at 25, and 25 actually doesn't have any other 25, therefore Uranus would be the next planet listed. Then I see that I have an exponent of 26, and I'm comparing Saturn and Neptune. Saturn has significant digits of 5.69. Neptune has significant digits of 1.02. Therefore, Neptune is smaller and would come next on our list. And then Saturn would be after that. And then the only planet that is left is Jupiter. So we've now been able to list the planets from least to greatest in regards to their mass. Now going back up to our learning target, where it says we should be able to compare values written in scientific notation as how many times bigger one is than another. This question 8, says how many times bigger is Jupiter than Earth? So we are looking at comparing Jupiter. How many times bigger is Jupiter compared to Earth? So we're going to divide Jupiter's size divided by Earth's size. So Jupiter is 1.89 times 10 to the 27th, and Earth's mass is 5.97 times 10 to the 24th. Okay, and we're going to kind of break this up. So I'm going to look at my first significant digits here, and I'm just going to divide those. 1.89 divided by 5.97. 1.89 divided by 5.97 gives us 0.31, and I'm going to round to the nearest thousandth, so 0.317. And then remembering scientific notation, I'm going to have that times 10. And now this is the neat part. Remember, we just worked with our exponent rules. 10 to the 27th divided by 10 to the 24th. That has a common base of 10. So since I'm dividing them, I'm going to use the quotient rule. So 27 take away 24 is going to leave 10 to the third. And so I get 0.317 times 10 to the third. Now the question that doesn't really answer how many times bigger, it kind of does, but not really, because if you were to say, oh, well, Jupiter is 0.317 times 10 to the third times bigger than Earth, that's kind of confusing. So we're going to change this number back into standard form. Paying attention to, I have a positive 3 exponent, so I am going to swing my decimal 3 places to the right, and so that tells me that Jupiter is approximately 317 times larger than Earth. Now, just a side note on this question, if you were to get a question like this on a state test that didn't allow calculators, which is very possible, that does sometimes happen, you can always use estimation. So 1.89, that's really close to 2. And 5.97 is really close to 6. So if we have 2 6, that's the same as 1/3, which hopefully we recall 1/3 is approximately 0.33. We can even add on a third 3 since we kind of know where we're going with our answer. And so we would have 0.333 times 10 to the third, which would be approximately 333 times larger. So really depending on what kind of question you get, are you allowed to use a calculator? Are you not allowed to use a calculator? If you're allowed to use a calculator, then obviously the first process that we did would be the way to go. If you're not allowed to use a calculator, estimation still gets you pretty darn close. All right. Our last question says, for number 9, it says, how many times smaller is Mars than Neptune? Okay, so if we compare Mars, Mars is 6.42 times 10 to the 23rd. So 6.42 times 10 to the 23rd divided by Neptune, which is 1.02 times 10 to the 26th. Again, if I focus on 6.42 divided by 1.02, 6.42 divided by 1.02, that gives you, again, I'm going to round, so that's 6.294 approximately times 10. And then if I look at my exponents here, 23 take away 26, that would give me -3. So if I'm converting this to standard form, since it's a negative exponent, I'm going to be swinging my decimal to the left. So that would give me 0.006294 times smaller. Okay, and if we were to round, 6.42, it's below 6.5, so I would say that's approximately 6 divided by 1, so that would be 6, and then times 10 to the negative third, so that would be approximately 0.006, which again is pretty close to what we got. Okay, so depending on if you have a calculator or not, you have two different methods that will help you solve this, smaller, not less. Okay, go ahead and try the practice and see how you do.